Let us look at proposition number 13 of book 13 of Euclid's Elements. The proposition says to construct a pyramid, to comprehend it in a given sphere, and to prove that the square on the diameter of the sphere is 1.5 times the square on the side of the pyramid. Basically, here in this proposition, we are looking at the relation between the side of the pyramid inside a sphere and the diameter of the sphere. So let's see how we can understand this. Set out the diameter AB of the sphere. Cut AB at the point C such that AC is equal to 2 times BC. So here AC is 2 times BC. Describe the semicircle on AB. Draw CD perpendicular to AB. Now set out the circle EFG with radius CD. And let's mark the points. EFG is the circle with radius CD. Now inscribe an equilateral triangle EFG in circle EFG. The way I have chosen these points is they will form a equilateral triangle to avoid having too many points. Take the center H and draw EH, FH and GH. Draw a line perpendicular to the plane of EFG and cut HK equal to AC. So let's draw a perpendicular line to the plane EFG. Let's mark a point, or rather, let's cut this line such that HK is equal to AC. Draw EK, FK and GK. KH is perpendicular to the plane EFG, which means that each of the lines HE, HF and HG are perpendicular to HK. Why? Because HE, HF and HG lie in the plane EFG and they touch the line HK, which is perpendicular to the plane in which these lines exist. AC is equal to HK, CD is equal to HE, and angle ACD is equal to KHE, and they are both right angles. So which means AD is equal to KE. Because these two triangles are congruent, which triangle here? We have to join AD for that. Similarly, we can show that KF is equal to KG is equal to AD. Now, AC is 2 times BC, which means if we include BC as well, then AB becomes 3 times BC, which means we can say AB is to BC is equal to the square on AD is to square on CD. And to show that this is true, we will look at it later. This is described as a separate lemma. That means since AB is equal to 3 times BC, AD square is also 3 times the CD square. Also, FE square is equal to 3 times HE square, since CD is equal to HE. So, DA is equal to EF. So, which means DA is equal to KE is equal to KG is equal to KF is equal to EF is equal to FG is equal to GE. So, the triangles EFG, KEF, KFG and KEG, they are equilateral triangles. So a pyramid EFGHK has been constructed. produce the straight line HL in a straight line with HK and make HL is equal to BC. So let's do that. So HL is equal to BC. Since AC is to CD and CD is to BC. Since CD is the mean proportional between AC and BC. And AC is equal to KH, CD is equal to HE, and CP is equal to HL. So we can do the substitutions. So this becomes KH is to HE is equal to HE is to HL. So we have rectangle KH by HL is equal to the square on EH. Angle KHE and EHL, they are both right angles. So which means semicircle described on KL passes through E. So let's draw that. And now KL remaining fixed if the semicircle is carried around and restored to the same point from which it began to be moved, then it also passes through G and F. So let's do that. Let me demonstrate that to you. Now I'm going to rotate it. So what do I end up with? I end up with a sphere. AC is 2 times BC. That means AB is 3 times BC. So in conversion, AB is equal to 1.5 times AC. AB and AC we have. And we know that AB is to AC is equal to the square on AB is to square on AD. How? Because if we join BD, then you will notice that AB and the square on AB and AC and the square on AD. So here AD is the hypotenuse in this triangle and AB is the hypotenuse on this triangle ABD. And here angle ACD is a right angle and angle BDA is a right angle. So AB is to AC is equal to AB square is to AD square. Means since AB is to AC, we have this relationship. That means AB square and AD square will also have the same relationship. So we can say AB square is equal to 1.5 times the square on AD, which is what we had to prove. Diameter of the sphere square. So here diameter of the sphere is what? Remember, set out the diameter AB of the sphere. So AB is the diameter of the sphere is equal to 1.5 times the side of the pyramid square. And side of the pyramid is AD. So what we have achieved is we have constructed a pyramid inside a sphere. And we have understood the relationship between the diameter of the sphere and the side of the pyramid constructed inside this. Of course, the pyramid that we are talking of is made up of 4 equilateral triangles, what is called as a tetrahedron. Now, remember, here we had one step. AB is to BC is equal to AD square is to CD square. How we arrived at this, we had left it out to be looked at as a lemma. So now let's look at this lemma. So here we have the same figure, and what we have to prove is AB is to BC is equal to AD square is to CD square. Now draw AD and BD. Describe the square AF on AC. Complete the parallelogram FB. Then triangle DAB DAB is equiangular with BAC. So since it is equiangular, we can say AB is to AD as AD is to AC. Sides about the equal angles are proportional. So that means rectangle AB by AC is equal to the square on AD. AB is to BC is equal to EB is to BF. How? We have AB is to BC as the figures on them. And the figure on AB is BE. And figure on BC is BF. Now EB is equal to rectangle AB by AC, because AF is a square. So AC is equal to AE. The rectangle itself is AB by AE. But since AC is equal to AE, we can say BE is equal to rectangle AB by AC. Now, similarly, FB is equal to rectangle AC, because CF is equal to AC. So AC by BC. So our proportionality becomes AB is to BC is equal to rectangle AB by AC is to rectangle AC by BC. Now, since CD is perpendicular to AB and C cuts AB, CD is the mean proportional between AC and BC. That is, rectangle AC by BC is equal to CD square. So that means AB is to BC is equal to the rectangle AB by AC is equal to AD square, and rectangle AC by BC is equal to CD square. So AB is to BC is equal to AD square is to CD square, which is what we had to prove as part of this lemma. So that was proposition number 13 of book 13 of Euclid's Elements, including this lemma. Let me just remind you again, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.